Hello, welcome to one of our lessons, and today I'll be teaching you fluid dynamics, especially one chapter called microfluids, and I'm showing the distance between molecules in fluids, especially in liquids, gases, and solids. Okay, let's go. Uh, Distance in water, we know in water, let's say is water. At each point that the lines cross, there are the molecules in water. Okay, and from this we can actually estimate by calculation what's the distance between here, so here, which distance is this. So to do so, we have to know, or which we already know, that we can actually measure in the laboratory the density of water, which is equal to approximately 100 kilogram meters cubic. And we know that 1 liter of water is equivalent to 1 kilogram. 1 liter of water volume is equivalent to 1 kilogram mass. That thing we can also calculate. We know that the mass density of water is equal to the mass over the volume. And then what we know, we're saying that in 1 liter of volume, what's the mass of the water? So we'll actually find the same value of 1 kilogram, which means density of water times the volume is equal to the mass. And density of water is actually 100 kilogram meter cubic times the volume, which 1 liter, and we have to convert it times, let's say, times 10 to the minus 3 meters cubic to 1 liter is equal to the mass. And then this one is with this one is with this, then the mass of 1 liter is equal to 1 kilogram. That's what is here. Okay, and from this we know as well the formula given that the mass of water is actually equal to molar mass, okay, over Avogadro number times the, let's say, the volume. Okay, and we know as well that the volume is equal to let's say it's equal to x1 times x2 times x3, which if we assume that it's a meter cubic, which we assume it here, then we'll say that x1 is equal to x2 is equal to x3. So this gives us that the volume is equal to x to the power of 3. Okay, so our formula here becomes the mass of water becomes molar number, Avogadro number, times x3. That's the distance that we are looking for. And we know as well that one is it's a property that the molar mass of water is equal to 18 grams per mole per molecule, and the Avogadro number is equal to 6022 times 10 to the power of 10 mole minus 1. Okay, a little discussion about the Avogadro number. That thing actually it tells us the number of particles. Okay, I think I have to write this. Tells the number of particles contained in 1 mole of substance. Yes. So these particles can be these particles here can be ions, can be molecules, can be electrons, and etc. Okay. And since we are looking for that distance here, then we say that x would be equal to square of, let's say, molar mass over mass of the water times Avogadro number, that is, and then x should be equal to the power of 3. We have our molar mass, which is 18. We have to convert it in grams here. It's in grams here, and we have to convert this in kilogram, which is times -3, it's a kilogram mole over 6022 times 10 to the power of 10 3 times 1 kilogram. That one 1 kilogram, that one is mole minus 1. Okay, and if you do the calculation on this, we'll find out that the x here is actually equivalent to 310 times 10 to the power of minus 9 meters, equivalent to 310 nanometers. Okay, so this value here is actually the distance of molecules in water. Of molecules in water. Okay, that's the distance of the molecules in water. Thank you.